available. So today we are going to discuss about the surface modeling, freestyle, sheet metal design, assembly modeling, and detail design. Those first two topics are generally for the surface modeling, which is the again in the modeling. Generally, this surface modeling is used at the class A surfacing, the plastic part manufacturing, and in the automobile industries also. The surface modeling are using. These in this freestyle tool, you can directly import your rough import geometry, and directly from the drag and drop by using the mouse button, you can develop your whatever the shape you want. And in the sheet metal, you can do you will give the all the options about the sheet metal. And in the assembly modeling, which type of assembly we can do, which are the constraints, how we can do the assembly modeling if we are going to use the mechanism. So these topics we will going to discuss, and at the end the detailed designing, which is called as a drafting. So 2D drafting, how we can create the 2D drawings, whatever the models we have created, and how we can update vice versa from the model to draft, and draft window to model, we will discuss. So those topics we have discussed in the design stages, in concept design, modeling stage, detail design. This up to this we have now we reach, and today we will complete up to detail design. So after today, verification, validation, manufacturing, tool design topics we will take. So first one is the Creo Parametric Surfacing. We can define the parameters and constraint driven entities to create the complex and free-form analytical surfaces as well in the Creo Parametric Surfacing. Generally, Creo Parametric Surfacing, who needs it? The customers that want to define free-form and analytical surfaces using parameters, constraints, and calculations to define variable geometry and capture design intent. The business of value of a surfacing tool, it will reduce your time to upload your product in the market. It will reduce the product development cost. It will increase the styling and design to realize the price premium. What is the process improvements? By using the surfacing, how we can improve our process time. So in the 3D part design and surface modeling, can create the complex part design. Frequently require the surface to handle the complex geometry and design scenarios. By using surfacing, we can create the complex surfaces. You can see in those images, there are very complex features are generated in those parts. By using the surfacing, we can very easily and precisely we can create this type of plastics or sheet metal parts. The technology and capability are available in the surfacing tool. You can easily model and edit the complex surface geometry. We can develop the complex surface geometry using sweep, blends, and boundary blend surfaces. Also, we can create the analytic surface using the extrude, revolve, and fill tools. As I told on yesterday regarding the modeling tools, we can also create the analytical surfaces like extrude, revolves, and fill tools. By using the drive complex surface geometry, you can also using mathematical equations and functions also. So how we can control our surface geometry using the mathematical equations and functions, I will tell. And again, all multiple tools are available for the editing the surfaces like trim, copy, merge, and surface transform. So these are the all points. Points are about the surfacing. Just these are we are talking only about the technical surfacing, and in which only surfaces. There is the other two types are also available in the surfacing. Second one is the freestyle surfacing, and one is the ISDX, which is interactive surface design extension. In this interactive surface design extension, you can create a class A surfaces, 3D curves, and whatever the geometries you want to create, there are some flexible tools are available for it. About the assembly modeling in Creo parametric part and assembly modeling. Creo having the powerful parametric design capabilities to create the complex geometry and capture design intent. Generally, who needs this part modeling and assembly? Every customers that require the power of flexibility to model any geometry, regardless of shape, size, or complexity. What are the business value of the part modeling and assembly modeling of Creo parametric? It will reduce our product cost. It will reduce the time to market. Again, it will reduce the product development cost and develop and define new markets. It will in the process improvement stage. We can directly create the 3D part modeling, 3D assembly modeling. We can in the 3D assembly modeling itself in the assembly environment. We can also draw the we can also create the part files also itself in the assembly modeling. The technology and capability used in the part modeling and assembly can create the precise geometry regardless of model complexity without compromise. This part modeling and assembly, we have some of the major customers in the Nashik, like VIP Industries, Fortuna Engineering, Apros Polymers, Crompton Greaves. Those customers are totally working on this Creo parametric part and assembly modeling. So in the VIP bag industry at Satpur, they are creating and developing their bags totally in the Creo parametric window. So we can capture the engineering requirements using the feature parameters, constraints, and relations. We can easily create and manage the complex assemblies using tools to manage and improve the system performance. Also, we can perform the global clearance and interference studies using the static components and real-time collision detections also. One of the best feature of our part and assembly modeling, we can check the collision detection. If one part is moving component in our assembly, we can check the collision between the two parts by using this collision detection test. I will show in software window. And at the next, seamless integration with PTC solution to facilitate the concurrent engineering. Whatever the solutions we talk on yesterday and up to the next sessions, so all these part and assembly modeling files we can directly send to our native Creo extensions. What are the tool design or simulation or any NC modeling? All these directly part or assembly files we can directly open and start working on it. So Creo parametric freestyle design, the third topic, it has the capabilities to speed the creation of high quality freeform surface geometry. You can see in those images, there are some of the complex surfacing and the non-parametric shapes are available. By using this freestyle design, we can easily create these non-parametric shapes. Generally, who needs this freestyle design? Any customer that creates the freeform surfaces geometry to satisfy aesthetic, ergonomic, and functional design requirement. So generally, we are also use this freestyle design in these bottle designs. We have some of our customers in the product development of bottles. For the agricultural or the pharmaceutical equipments, the bottles bottle is very important. So every customer wants the different and unique shape for the bottles. So by using this freestyle design, we can create very easily this type of critical shapes. Business value, again, reduce time to market, reduce product development cost. It will improve the product styling and competitive differentiation. It will improve the process in the conceptual design, performance, styling, surfaces creation, and in the technology and capability. By using this freestyle design, you can create fast creation of high quality surface geometry. Generally, whatever the surfaces we have creating in these technical surfacing as well, we need to do the one analysis which called as a reflection analysis. By using this reflection analysis, we can observe the quality of surfaces, and the whatever the two surfaces will get connected, it should be very smooth curvature should be there. So this type of analysis we can very easily clear by using this freestyle design. We can enable the novice users to create a high quality style surfaces geometry. It will no need to define the curves and surfaces, no need to understand the curves and patch structure. Ability to align freestyle geometry to external entities. So this is about the freestyle design. I will show again one best example for it, and next one is the sheet metal part design. Yeah, we can create the fast creation of accurate sheet metal design and flat pattern of geometry. When we are working with sheet metal design, at the end we need to development length for the every sheet metal model, because whatever the sheet metal work we have to do, we need to one raw material as a single sheet. So for the single sheet costing, or if you want to order, if you want to order the raw material sheet, we need to total requirement of our product development length. So by using the sheet metal part design, in the sheet metal there are some of the very easy tools are available. By using this, we can easily get the flat pattern geometries, and the we can give this development length for the design and manufacturing very easily. It will again reduce the product cost, time to market. It will reduce the time to market and reduce product development cost as well. The technology and capability used in the sheet metal, we can create the complex sheet metal parts as well. We can place creation of walls, hems, notches, bend reliefs. These are the all important terminology you can see in this sheet metal. Like what is the notches, what is the bend relief, I will show. We can directly editing of sheet metal walls and features. We can fast creation and placement of sheet metal form features. Uh, the forming, punching operations also we can do in this sheet metal. Can automated creation of sheet metal flat patterns with accurate bend allowance calculations. Software having the inbuilt bend tables for it, for the calculation of bend allowance. And at the last, 2D detailing and documentation. In this 2D detailing and documentation, specialized capabilities to manage the component display and system performance. As I said earlier, uh, every customer that needs to document the product specification and manufacturing details. For that, we are using the technology and capability, automated creation of drawings using the standard templates. If you are using the standard templates, there will be some of the standard templates will available. By using these templates, you can automatic creation of drawings you can do in this Creo parametric also. Fast drawing, cleanup of dimensions, notes and annotations. Whatever the standard features like hole notes, welding symbols, uh, other if you are annotations you are giving or dimensions, you can directly it will get available in the drafting window. It will automatically creation the creation of associative bill of material. Automatic creation of views and ballooning for the assembly designs. You can easily creation of dimensions, geometrical tolerances, annotations, and it will support for all the industry standards like ANSE, ISO, ASME, and JIS. Let's take a look in the software window. So let's start from the surfacing. Generally used for the curvature surfaces, smooth surfacing where we want to use. So for that, I am opening one special model. You can see this stapler model. Just take uh, overview of this stapler model. By using this, we can finalize our final model. You can see here is the lower end, lower part of our stapler, and here is the rubber pad for this model, and first one is the upper side of that model. So I will show how we can use this surfaces and how we can create these surfaces by using this surface model. So I will show how many surfaces we have hidden items. I am hearing on head. Show and at the layer multiple surfaces. For the this stapler model, you can see I have created here this surface. You can see by using this extrude feature, I can create these surfaces. Once I will show. If on the this center plane, just click directly on the extrude feature, and for that you will get this surfacing sketching window. Is my speed is okay? Hello. Is
So
my speed is
yesterday,
okay?
yesterday it was really fast, but today it is
Okay.
okay.
Okay. I will take the precautions for it. You can see I have created one of the sketch, which is a single just line, and in which the curves and single separate lines I have created. If I am clicking on this, you can see here is the surface option is available. Click on the surfaces. You can see I can create the surfaces for it. So here is the depth option is available. By using this depth option, we can create the symmetry. We can create the up to the next surfaces. If you want to remove the material, we can remove this our solid material also. And the some of the options like here is the internal sketch. You can edit again if you want to edit the sketch. You can edit directly from here also. Otherwise, if I am click on the OK button, you can see surface get created. The in the Creo parametric surfaces, whatever the surface or surface modeling you are doing, here is the special sky blue color will be appear, and by using this, you can use you can just understand the what are the surfaces we can create. You can also change the colors for it. So here is the I am selecting the one of the surfaces, and in the editing toolbar you can see the Solidify one of the tool is available. If I am deselecting it, you can see this toolbar again get off, disable. So what is the use of this Solidify? I will show. If I want to remove the upper side material, you can see this type of cutouts also you can do by using this surfacing tool. In the body options, whatever, if you want to cut the geometry from the bodies, references are available. If you want to fill with solids, these are the options are available for we in the surface models. So I am again opening new model. So for the surfacing, generally sweep, revolve, extrude, these analytic shapes also you can create. I am enabling this datum display planes, and again I am creating the sketch for the bottle design. I will show the example how we can uh, here is those toolbars also you can manage. If you right click on this toolbar, you can see all the shortcuts are available and what type of shortcuts you want this in this toolbar. You can click on this, so you will get this tools on in this shortcut quick access toolbar. So here I am creating one arc, and for that here is the constraining option. I am doing here as a coincident constraint, and I can set the size for the curve and all the distances. Let's see. And for the opposite side of center plane, I can just select it, and here is the mirror option is available. Just click on it and select the center line. You can see these sketches get developed. Click on OK. On the next surfaces, again, sorry, we need to select again the sketch. Just click on the sketch. Here is the coincident option is available. So center of this arc, we can coincident. Here is the distance 250, 125 distance. One, and the and again if I want to mirror it, select it and click on OK. And you can see 4 curves are created. And this option, I just want to cross check the all the dimensions for the both curves. Just double click on it. Here is the radius for this curve is R300, 125 distance, and for this tool I can edit directly from here. It's 300. And the entire to 125, 125. Now you can see all the curves are equal. For it, so I just need to take the references for it from the normal to parallel. You can see. Otherwise, just select the front and second. You can see here this type of way. You can also insert the multiple planes on this modeling. And I am drawing one of the sketch. You can disable this datum display, so you can take the references. Here is the reference option is available for the reference. By using this references, you can create the take the reference for the whatever the shapes you want to develop. You can see, just click on OK. And at the bottom, we need to again develop one plane. Is it first then in that you can draw again on sketch. Now here I am drawing as a different shape. Created some one simple modeling for the surfacing. For the creating the surfaces, here is the one option we have. It's called as a boundary blend. By using this boundary blend, you can create the surfaces. Select two side surfaces and one more. And for the second direction, just click on the second direction. First one direction, this one, and second direction. Now you can see all the surfaces get created. And after creating the surfaces, you can directly click on the rounds for giving the rounds on these surfaces. Radius for these rounds you can manage as your own. And in the sets, lots of options for the giving the rounds. Okay. If I am changing the shading with orientation, my model will, I want to change the shading with reflection display type. You can see the smooth curvatures, and whatever I have told that how we can check the reflection analysis. The reflection analysis option is available under this analysis toolbar. Inspect geometry. Here is the reflection option is available. For that, you can directly select the quilt. Here is the smart filter option is available. By using this, you can select the whole quilt. Now you can see. By using this toolbar, we can check the surface finishing in the automobile industry, as well as the product development in the plastic manufacturing companies as well. All this reflection analysis get used, and by using this, they are trying to give the finish for this for their final models. Here is the fill tool is available. By using this fill tool also, you can create close our loops. And here you can see, and at the bottom side, we need to create the boundary blend, or directly we can create on the extrude on the front plane. So here I am just adding one arc. Again, I am coincident with center line. It will convert as a surface, and I want as a symmetric from the center plane, and I can again draw from here. Click on disable the datum display planes. Now you can see in the model tree we have three different types of surfaces. If I am selecting one of the surfaces, you can see there here is the solidify option still not open. If I am click on the any of the surfaces, because whatever the surfaces we have created, this not counted as a single geometry. For the counting the single geometry, we need to merge those surfaces with each other. You can see I am selecting the first boundary blend and second fill option. Here you can see the merge tool get open. By using this merge toolbar, it get merged. You can see intersect or join option will get automatically open. And at the next, by using at the end, I want to select this, and you can see again merge option will get open. Now you can see if I am click on OK, the extra surfaces, whatever the extra surfaces are available, these extended surfaces, those extended surfaces from the curved surfaces, it will get automatically removed. You can see. So very fast, quick, by using those surfacing tools, we can create these surfaces. So here I am hiding these two sketches. We can observe this. surface modeling. Here I want to add the round for this edge as a 20, and at the bottom again I want to add the round surface. There you can see. So how this way you can create the surface model. If I am click on the surface, here you can see now the solidify option will get available. So when I am clicking on the solidify model, my model will get in the solidify. Now I can check by using this section. You can see the full surface will get solid surface will get appear. If I don't click on the solidify, and if I am taking this section, you can see the hollow area will you can see at this section. Disable. I am disabling this section. I can also create the neck for the bottle. If I click on this as a solidify, and after that I want to create as a uh, uh, neck for this bottle type. Be okay, and distance will be 50. I am directly edit this shape by double clicking on this. Let's see, origin, and I can again I am adding the round for these smooth surfaces. Uh, I am here. You can see I have created like one of the like bottle shape. So after that, I want to create the shell. I want to hollow this bottle. For that, here is the shell option is available. Click on this shell option and click on the top surface. You can see all the bottle will get surfaces automatically get shell, and now you can give the thickness, whatever the thickness you want to add, and you can use this product for your further development. And here I am giving the color for it. Here is the library for the appearances like standard, paint, plastic products, injected, matte finish, frosted. If you want to clear bottle colors, you can set from here. Now you can see. I can also add the tablets. How in this bottle I will show just once. I am changing this appearance for this bottle, and I am changing the color like a medical syrup bottle. Can also edit this appearance from here. You can see in this color box a color wheel is available. By using this, you can change the colors for the bottles. Click on the, if I want to show the tablets, and so the surface, bottom surface, I need to select and click on the extrude. I'm just creating 2 to 3 tablets. Click on the OK button. Find the references. Solve. Close. OK. The sketch should be fully closed. Otherwise, it will take the. I need to give the references for it, the horizontal and vertical references. In the opposite direction, just as a thicknesses. 10 mm. I can change for it the color for it using this view appearance as a white color for this internal surfaces. Click on that and give the white colors. Now you can see it looks like a tablet jar. So this type of surfacing models you can create very easily by using the curves, boundary blends, fill, and the other styling boundary blend surfaces tools. By using this, you can show this type of surfaces. Also in the appearances tools, various options are available. So I will just if I want to select the internal surfaces, I need to right click up to that surface. You can see. So let's move towards the freestyle surfacing. How we can use this freestyle tool in the surfacing. So I am closing this model. For the freestyle, just a minute. For the freestyle, we have the model in the toolbar. Just give a minute for the freestyle surfacing. You can see in this model, this is the car side model. How we can create the freestyle, how we can create this type of models by using this freestyle tool. So I will show one by one. So for that, I am importing here as a two images for the creating the model. Here is the top side and the front side models on head. Now you can see if I am dragging my model tree and the upper side, you can see above the freestyle. On the first front side, here is the front view of this mirror, and on the top side, here is the top side of the mirror. So by using this reference or these sizes, you can create the freestyle surfacing. Here is the freestyle tool is available. Just click on it, and the separate freestyle ribbon you will get available. In the multiple options, multiple tools are available to develop the primitive shapes. Here is the primitive shapes are available. Open primitives means surfaces are available. You can just drag and drop it. Closed primitive shapes also available for the creating the closed boundary model. So here is the freestyle primitive shape is available. You can use by using this 3D dragger, you can just drag whatever this on the screen you want to drag. So select all the area, place it on the center of this image, and click on the scale button. So I can reduce its size by width and any area. So after that, just select the, can directly select from this side also. Otherwise, you can select the edges and node points of this rectangle and click on the extrude button. So you will get the extra surface model, and you need to manage it. So you can see fastly, you can just drag and drop those node points or those areas. So how we can create the sharp surfaces, I will show. If I am selecting those front two surfaces, and here is the hardness crease option is available. In the hard and soft, you can just set the values for it. Now you can see, if for the front surface I want the hard as a planar surface, I am just selecting is as a planar and clicking on plane, front plane. I am again I want to extrude that feature. Just select whole this area and manage the as per the image size. So you will get the desired shape. Just drag and drop the surface area, and here now you can see my almost front side area get developed, and from the top side I need to manage it. Here you can see. So this way we can very easily quickly manage our model, create the complex surfaces also by using this Freestyle tool. Select this. You can see here is the almost shape for our model I have developed, and again I am replacing it. From the top side again I can cross check, and you can see the almost shape get completed. For the handle for this mirror, how we can create and how we can differentiate this specific surface area. Here is this face split option is available. By using this face split, I am selecting here as a 75% face split. Otherwise, I can also change the face split option as a 50%. And now you can see, I can just Control Z, and I can click on the extrude button. So you can see, and I need to just drag and drop. I need to give the desired shape for this model. So here is the internal edges of this handle area. So I can also scale it from here, and I can reduce its size. And from the right side, I want as a hardness crease surface as a 100%. I can set from here, and from front side again I can set its length from here, and from the top side again I can set whatever the surface is. I can rotate it again. Now you can see. Of how I can again give the edges at these surfaces also. If I want the edge in the middle for the LED lamps, I can also select this edge, and here is the edge split option. Click on it, and first option is available. So after that, you need to press the control button and select the edges and click on the hardness. and you will get the click on OK. Now you can see the almost our surfacing model get completed, and after that we can also again hide the our images. Here is the top image I want to hide, and front image also I want to hide. Click on OK. Now you can see the model get completed, and after that I just want to solidify it. Click on the freestyle, click on the solidify option, and click on OK. After that I want to shell it. Click on the surfaces, want to open, and in this shell you can see 4 mm thickness I have given here. And if I want to check the surface finish, so I can check by using the reflection analysis. Here you can see the continuity between the two surfaces, or if I am selecting the whole model, now you can see the continuity between two models. Here I have specifying one the sharp edge, though, so that's why the surface continuity get disturbed here. Otherwise, you can see every surfaces, every patches, it get continuity. 100% continuous surfaces are created. So by using these freestyle tools, you can create this type of models. Again, so here is the in the reflection analysis, color scheme is available. Lights you can manage, spacing manage, angle you can manage for the lighting. Click on OK. Again, I can change the color for it in the plastic, frosted, and as a clear. Sorry, glossiness. I want here as a blue color. Now you can see very precise geometry also we can create by using this surfacing tool, freestyle surfacing tool. So I can directly use as a this model for the modeling also. First of all, after the plastic, if this part will be plastic, we need to do the draft analysis for the core cavity extraction. Here is the draft analysis option is available, and by using this we can verify the product is ready for the draft creating the core cavity. So this way we can use these freestyles and these surfacing tools. So let's move towards the sheet metal tool. Okay, I'm closing this model and opening one of the sheet metal model. Sheet metal. I'm opening this model as a separate entity from the assembly. Just click on it, and you will get this shortcut toolbox, and here is the open option is available. Here I am changing the type of this viewing type. So now you can see there is the total user interface is different. Almost 60 to 70% tools are changed for the sheet metal. You can see here is the flat, flange, extrude color, planar, boundary planes. All the different tools are available in the walls. Multiple various twist, revolve, sweep, blades, extrude cut, forming tools are available. Ripping tools are available. So how we can create one by one, I will show. So for the going in the sheet metal, you can click on the new parts. Here is the sheet metal option is also available. Just click on, if you will click on the it, you will get the separate toolbar option. So when we are working with sheet metal, it needs first as a planar surface, which will be the our first surface. So here is the planar option is available, and click on the front plane. So after that, I am creating here as a rectangle, and I want this open-ended rectangle, and I can set the sizes for it. And there, if I am click on the OK button, for the extrude, $150 and 300. I want this as an open end. Okay. Now you can see automatic thickness get as a 1. Here I want as a 5 mm thickness. Now you can see the radius for the sheet metal automatically get collected, and I can set the sizes as and symmetricity from the center plane. You can see the sheet metal tools you can create. Here is the bending allowance. As I told, if I want to bending allowance adding here, you can see by K factor, by Y factor as a bend table. You can also use the bend tables. In the option, symmetricity option is available. For the bending, what type of radius we want to use at this bend area, you can select from here. If we want to do into thickness, so this will automatically get collected, and if you want to inside outside, it get, we have this flexibility to select the radius for the bend areas. You can see. So after click on this OK, you can see the sheet metal first wall get created. So creating this first wall, here is the flatness and flange options are available. By using this, like if I am using the flange option and click on the internal edge, so it will get created as a outside. I can set the size for it as 100 mm. Here is the thicknesses, meter cuts option, bend reliefs option is available. How we can use this bend reliefs and internal cuts will show. Here is the bend position option is also available. From the inner side, from the up to the next surface, if you want to add the specific dimensions, from the internal area, here you can see as a 10 mm. You can see and set from here. The length, chain end length, we can set from here. If you want to edit the whatever the sketch is available, if you want to change the angle as a 45-degree, now you can see and develop this this type of sheet metal. So at the other end, if I want to add the flat, again I am selecting the internal edge. Now you can see in the flatness, trapezoidal, L-shaped, T-shaped surfaces automatically are available. By using this, again you can here enter the angles between those surfaces, between adjacent surfaces. Here is the bend allowance, bend positions, thicknesses options are available. We can set the size from here as 100 mm and distance as a, you can see. Okay. So if I want the extrude cutouts from the surface, here I can set and click on the as a, from the palette, I can use the hexagon honeycomb shape in small size. Click on OK and directly click on OK. Now you can see automatically extrude get cut out up to the next surface. Now you can see if this extrude cutout I want to apply on this full area, so I can just select it, right click, and here is the pattern option is available. So different type of pattern, which is the fill pattern option is available. So I will show how we can use this fill pattern. This surface we need to set, references, sketch we need to define. So this whatever the sketch we have developed on this specific area, and click on the OK. Spacing is as a 10. And see or as a distance as a 20 mm. Click on the right side. You can see here is the grid patterns, multiple options is available. I am again changing the distances between them. Here is the grid pattern type is available, diamond shape is available, hexagonal shape is available, round shape, rectangular shapes. If I want here as a hexagonal shape, just click on it and all the holes will get created. You can see. So these are this type of sheet metal extrude cutouts we can create. If you want to add the forming operations, the forming tools are available. Click, you can directly import these shapes and we can place on the top side and give the references again. As like if when we are creating the holes, standard holes, so this way we can give the placement as a center, sizes 0. And see just failing it. I'm clipping the direction. I can see the forming operation get completed. Again, the diaform sketched forms is also available. If I'm click on this surface, I can also create these sketched forms. And click on OK button. Now you can see in the opposite direction. If I want the internal edges round, you can see, and the outside edges also we can create as a roundness. If I can create one flange at this specific internal edge. So here I can show the reliefs for the bend relief, corner relief, how we can set the corner reliefs and bend reliefs. Here I am giving the bend relief as oblong. Here you can observe this oblong, or if you want to relief as a rectangular, now you can see from the both side you can observe the bend relief we can give at this specific area. So here is the bending options are available. Reefs, stretching options is available. By using the stretching, the sheet will create as a stretch. Here you can see. Meter cuts also available. Click on the OK and the Control D. And at the last, we need to we need to flat pattern of this whatever the shape we have created, and we need to development length for it. So for that development length, we have here the option flat pattern preview. By using this, you can see the total requirement of length for doing this type of sheet. Here is the flat pattern length and width is available. And again, if you want to unbend this specific area, just click on the unbend. You will get the unbend view of this your model, and which are the angles get created. You can see you can also use these angles in the drafting tool. You can see. So if we want to again bend back, we can directly delete this unbend feature as well. Otherwise, we can also, here is the bend back option is available. By using this, and again rebend the our part. We can anytime we can change the size, values, number of patterns, spacing distances, and 50. Click on OK. And again at the next, in the viewing, you can set the appearance as a metal, and here as a steel, finished steel. The one you can see. Okay, so we can also use this sheet metal in the assembly modeling. These parts, sheet parts, we can use whatever the flat patterns bending sheet metal operations will require. Let's move towards the assembly modeling. It is not displayed. As I told, I need to clear my previous work. So for that, I need to erase not display option. Erase. So let's move towards the machine, the assembly modeling. Here we can set the filter, type filters, new model, new block, advance. Here I can change the appearance for it. You can see there, here is the lots of components are available. I will show one by one how we can use the assembly tools. Just deleting those tools. And how we can assemble those plates on our model. I'm reviewing some of the fixturing points. I can see, and at the next, I want to delete this pulley. So in the assembly modeling assembly model environment, you can see the interface is different. Here is in the toolbars. In the model toolbar, you will get the assemble options and the planar options. You can manage your views. You can give the sections. You can also change the appearance in the assembly modeling. Exploded view. If you want the exploded view, you can say click on this exploded view. Your model will appear in the exploded view. You can edit the positions of your model in the perspective view. You can, here is some of the multiple options like analysis. All these other options are similar. Oh, here is the view. So I am deleting this plate and we again reinstall. For the assembly, here is the option for the assembly to import the part file in the assembly file. Here is the our plate is available. Click on the open button and place here. After that, we need to set the constraining. You can see here is the user defined features are available. If you want to mechanism run the mechanism, so for that you can create the pin, sliders, cylindrical, planar, ball, weld connections for the assembly. And if you want to direct coincident user defined features, here is the distance, angle, offset, parallel, coincident options are available. Here I want direct coincident option. So for that I am selecting this two holes for the coincidence. Next again this hole and this one. And for the bottom surface of this plate, I want to rest this surface on this specific surface. Now you can see my model get. Here you can see the status of the assembly. Here is the fully constrained option is available. Fully constrained comment is available. So by using this, you can verify your assembly. Click on OK. So this way, you can assemble the multiple options, multiple part files here. Again, I will show one more part file how we can assemble pulley and click on open. How we can assemble this pulley on this rotating shaft. So I need to create the mechanism between those components. So for that, here is the in the user defined feature, I can create the constraining type as a pin. So for this pin constraining, you can see in the placement option. Here is the in the connection, for the pin connection, the axis and translation, two types of constraining are requirement. So for the axis requirement, you need to select the two axes or two round surfaces for the giving the proper constraining. So here you can see I am selecting the inner surface. I am click off disable this 3D dragger. So the use of this 3D dragger, you can move your component in the assembly window. And for the giving the pin connection axis alignment, I am selecting the internal surface, round surface. I want to rest this surface on this shaft. So you can see it get aligned. And after that, for the translation, I want to rotate my. Here you can see I can again rotate. First of all, I need to fully rotate this model. See, and after that, I need to set the translation. You can see this surface I want to coincident with this adjacent surface. Now you can see the pin connection get completed. Here you can see the connection definition get completed. Now you can verify your connectivity. If you want to cross check the pin connection is verified. So by using this drag component option, you can see if I am rotating it, you can see the wheel get rotated, and with this wheel, the internal surfaces also, internal shaft also get rotated. So this way, in the assembly modeling also, we can very fastly we can use and assemble by using the manual constraining, automatic constraining options. And in the again, as I said, in the assembly tool, we can create, re-edit. We can create the models also. If I want to do some changes in this model in the assembly window, I can directly give these features in the assembly window also. I can add the reference and give the here I want to add the one collar for this model. 110 as a distance. Click on OK. Here you can see as a distance as a 10 mm, and I can again change my modeling itself in the assembly window. Give the roundness. Sorry, how to change this? My system get hang. Here you can see my feature get completed itself in the assembly mode. After the completing the editing of this model, I need to activate the whole assembly. For that, here you can see in the model tree, you need to just select the full assembly, and here is the activate window option is available. Just click on it, your full assembly will get appear. So this way we can again do the assembly modeling. And if you want to do the sections, click on it, the section plane. If you want to hatchings, check the hatchings. You can cross check whatever the models you have inserting. And in the section plane, you can see here is the interference option is available. By using this option, you can check the models if they are interfering with each other. So we can cross check it. Here you can see every model will get. You can see here is the intersection yet intersecting these bolts and these plates. So this way, here is the aluminum extrusion is available. So click on the cancel button. So let's move towards the 2D drafting and detailing. So for that, in the Creo environment, some of the shortcuts are available. We can call it as a map key in this search toolbar. You can use these map keys. You can see here I have saved the multiple map keys for it. If I want to open the new drawing, I am just entering the ND as a keyboard button. My assembly drafting window will get appear. You can see, and in this drafting window, you can see the drawing tree is available, and at the bottom the model tree is available. You can set the size those trees from here as well. Otherwise, if you want don't want to see this model tree, here is the option for hide the model tree. Now let's start the drafting. For the assembly, click on the general view. Here is the front view, top view, exploded view options are available. I want the isometric view, so that's why I'm selecting the no combined state. Here you can see, here is the default orientation isometric, trimetric. We can set from here. Here is the scale factor is available. Uh, if you want to scale, if you want to see the larger size of our model, you can set the custom scale. On the enter, apply. And in the section plane, if you are showing the sections in the drafting window, you can add the 2D cross sections from this window. I don't want here as a section, so I'm click on the next section. No section. Viewing state, view display tiles. Here you can see generally when we are calling these models in the drafting window, you will see this type of models display style as a follow environment. You need to select the no hidden as an option, or the hidden option for the tangent edges option you can set from here. And here is, now I want to set this model at inside this our format. So there is the lock view movement option is available. Just click on it and set in the internal side of our area. After that, here is the projection view option is available, detail view option is available. If I want to add the detail view at this specific area, like this gear area, I want to show the specific detail view of this area. I am just detail view, collected this detail view, and I can put it where I want. And here I can scale this specific form as a 1, apply on OK. Now you can see. So this way, auxiliary view option is available, detail view option is available. If I am inserting here as a front view, on apply, and now you can see my front view of this model will get available here. If I want to projection as a right and left view, just click on it. Here is the shortcut option is available as a projection view, and I can add the multiple views from the parent view, top view and bottom view. Here you can see, you can set the multiple views in the I can set the sizes and move whatever these areas I want to move. And for the drafting, here is the dimension option is available. If I want to give the dimensions for this plate in the assembly, I can set the dimensions. Sorry. And set the minimum maximum positions, sizes, dimensions, top and the bottom edge, and the maximum points of assembly. So this way we can add the dimensions. I will show again one more sheet with this specific plate. For that, if I want to change the model, here is the drawing model option is available, and by using the add model, you can view fixture in this model. Click on the, now you can see the isometric view I want here. After that, I want as a front view in this plane, apply, OK, and I want as a top view, and in this adjacent view I want the section view. Here from here, this window, you can add the vertical section, apply, OK. Now you can see, and I am removing this, rearranging these positions. For the drafting, again click on the view. Here you can see the dimension shortcut is available, show model annotations. Click on that and you will get all the dimensions regarding your model: 90 degree, 12.5, M10, 4 into 90 typical. So these dimensions we can add: 25 distance, 17 degree, and the total distances between them. So click on the, if I want to all the axes, from here I can add the axis. If I want to add the nodes, I can add the nodes from here. You can see I can manage these dimensions by click on this. You can see, and the diameter symbols. I can add this, and if I want to delete any view, I can again delete it. You can see again same way. These annotations options, show model annotations, automatic generated options are available. All the axes get generated. And for the drafting, giving the dimensions options, is the 25 dimensions, 90 into typical dimensions, 12.5, M10, 0.5. These are the options I want to add in this specific view. If I want to delete specific, now here you can see the radius, the arrows get merged. So for that, in the display options, flip arrow option is available. By using this, you can add the arrow as a note. 4 into typical dimensions, and if I'm hearing, you can see the sketch. I am adding this section. So if I want to show the where this section I have taken, so in the layout option, arrow options is available. By using this, how we have add this section from which plane. So this way, if I want to change the hatching type, just double click on this hatching types and click on the spacing, click on the half button, and you will get the hatching pattern. And here I want as a axis for every feature and distances from the bottom surfaces distances, total distance, apply, OK. You can see. So this way you can add the multiple dimensions here. So for the dimensions, we can manual dimensioning also we can create. You can see here is a 17.5 dimensions is available, and we can add the diameter symbol from this dimensions text toolbar. Here is the dimension option is available. If I want to add the tolerances, plus minus tolerances or any other tolerances, here is the options for the tolerance. If I want the plus minus, general, whole basis tolerances, if I want to add, here is the S7, S6 whole to, options is available. By using this automatic H7 tool type of options, you can directly, you will get the upper limit and lower limit of dimensions at this area. So similar way, I can also add the multiple manual dimensioning also I can do by this way, and click on in the dimensions text as a diameter symbol, and the symmetric tolerances as a none, as a 0.1 plus minus 0.1. I can add this here. So this way we can add the multiple dimensioning, and we can set this text where we want to set dimensions, and at the end, if you want to add the datum feature symbols, here the symbols option is available. If you want to add the datum feature for the what is the initial, what is the initial datum will be for the modeling, for the manufacturing, we can give the datum features. Now we can see for these 5 dimensions, I want to add the geometrical tolerances. So I can add the tolerance for these dimensions, and in the geometricity, I can add the flatness as 0.01, 100 micron or 10 micron value, and again with the references I can add the, you can see. So this way we can also add the geometrical tolerances. For the position 0.01, I want to set the value, and with the reference, if you have any reference with this internal axis, so we can set the references value also from here. So this way we can also do the detailed design of our parts, and if you want to add the note in the or the part name or side name, you can click on the note and part name. You can also fixture is the part name. You can create the multiple notes here and click on the save button, so you will get save option. After that, so for the again, let's move towards the assembly window. I'm erasing other the views. If I want to create a bill of material of this specific assembly, in the table tools, you can see ready-made quick tables are available for the bill of material. In the quick tables, you can see bill of material description with description table is available. You can see it get appear with the part name, quantity, description, and notes. So I don't want this type of table. I have created the specialized. So how we can create, I will show. Click on the delete. I have predefined tables are available. BOM, bill of material with weight. Here I am adding. Now we can see I want this type of format for my bill of material: serial number, part name, size, material, quantity, and weight of the every model. So after that, here is the ballooning option is available. Quick ballooning. You can directly click on the balloons options and you can directly manage it. You can directly manage from this way. Quick ballooning option is also available. You can manage this bill of material by using this with the help of bill of material, you can manage this balloons. So this way we can create the drafting. If I want to create this as a PDF file, in the files toolbar, click on the save as, and here you will get the PDF option. I want to this PDF I on the desktop, click on the OK, and the PDF will get created. Regarding the drafting, I will show some best examples again. Here you can see the PDF we have created. So model, bill of material, and the ballooning options, detail view, our template, automatic files name here get. And close this window, and in the annotations, symbols are available, geometrical tolerances, dimensions, sketching tools. If you want to draw any sketch in itself in the drafting window, you can add from here. Legacy migration. All the tools are available. And in the sheet, you can add this type of hatching for these models. And at the next, if I want to add the auxiliary view for our model, if the model having the taper shapes and we want to define those taper areas, so for that way we can use this auxiliary view option. Here is the sheet, we can add the multiple sheets, and if I want to show you how we can associativity with the model and the file. Here you can see the distance for this groove. Distance for this counter bore hole is 6 mm. I can change at here also. If I am changing this whole depth as a 8 mm and click on the regenerate, it get updated, as well as it will update in the model also. If I want to open my model, just click on the model tree and right click, your model will get appear. Now here I can also cross check the depth of this hole. You can see 8 mm depth is available, and if I am changing the depth from here also as a 5 mm, double click 5 mm, enter, and regenerate the model and save the model. And if we go again in the drafting window, you can see the dimensions get automatically changed. These are the associativity 2D to 3D and 3D to 2D we have available in this Creo drafting environment. So this way you can also edit your models itself in the drafting window. And here I am showing some example like whatever the types of these tolerances we are using, I will show in the preparation drawing properties. Here you can see the tolerancing standards, ISO standards we are using here. Here is the different standards like ANSI, ASME standards is also available for the tolerancing, and we can also check it. So I am giving one last example for this assembly. So how we can cross check this collision detection test. If our model will get collide with adjacent part, how we can cross verify, I will show. Here I am creating a simple assembly, just a lever assembly like. So by using this assembly, I can cross check the where the my model get collide and which area I want to cross check it. Here you can see on these 2 to 3 areas my model get collide. If you are seeing this red area, my model get collide at here. I'm again dragging by using this drag component. So this way we can cross check our collision detection. So this option collision for the collision detection, you need to go in the file repair and in the model properties option, and in the model properties you can see in the assembly tool the collision detection option is available, and here you need to set this collision detection as a global collision detection option. So by using those options, you can cross check your collision options with the adjacent assemblies. Let's see. So how much area our model get collide with adjacent? So we can check from this way. So let's take a question answers.
Hello, sir.
Hello. Yes.
Sir, where do you get those sheet metal and freestyle options?
The sheet metal option, you need to open your model new, and in the part file here you can see subtype is available as a sheet metal. So if I click on the OK button, MMNS template, and you will get this sheet metal environment. Got it?
In model, where do we have to go?
Yes, we can also. I didn't get your question.
No, this sheet metal and flat options. From where do we get these options?
Okay, in the sheet metal window. So in the again, I am opening one sheet metal part. You can see this sheet metal components. I am opening one of the component sheet metal part. You can see those all options are available. For the unbending and bending option is available at here. Just click on it, unbend, and the reference main body reference is should be this, and I need to remove this rib area. You can see. You want to this option?
Yes, sir, I got it.
Okay, here is the unbend option is also available, and if you want to bend back option is also available at here. By using this, you can bend back your model on the horizontal. And for the freestyle option is available in the modeling. Here you can see in the modeling option, the model tree, under the model tree, freestyle option is available under the surfaces toolbar. Have you got this?
Yes, sir.
Okay, okay. Any questions, other?
Sir, what is the difference between flat and flange?
Okay. I am moving toward this model. Okay. So for the flatness and flanges, I will show. If I click on the flange, you can see the flanges are generally used for the connection elements like open flush. You can see these type of flanges you may observe for the computer cabinets or any other connecting elements, you can see. So these are the options are available. Generally, we are those flanges options we are using for the connecting elements. You can see for the fitting purpose. If we are designing with sheet metal model, so this type of options we need to use. You can see I joggle flush and at the look, you can see these type of connecting or the locking options are more options are available in the flange, and at the flatness flat view, you can see those options will not available at here. So if you are creating the flat sheet metal area, so you can select this flatness, and if you are creating any curvature or any connecting element or any locking system, by for that you need to select this flange area, flange option. You can see here is this those these are the difference between those flat and flange option. Have you got this?
Yes, sir. Sir, when we create the flange at two alternate side, there's the gap between the two flanges. How we feel that?
So for that, I will show one best example for it. If I am extruding on the top plane, we need to fill that gap manually. Clicking on OK, and I want the OK. And now, if this sheet where I should have to join this sheet, I need to create the one rib. For that, I am selecting the center surface area. So now you can see here is the rib get created. Now I can add the flange, and here in the flange, duck option I can use. Here you can see I am selecting the duck option, and on the opposite side, I can see the distance. Here is the bend position. I can use this sketch rip as a solid. I can create the gap again. Click on the rectangle, and you need to create this type of gap. 10 mm gap you can create. Now sorry, redrawing it. In the sketch rip, selecting sketch rip option and the surface, and in the rectangle I am creating as a 10 mm gap. By using this rip option also, otherwise I can use the extrude cutout option also. If I am creating as a 10 mm distance, click on OK. You can see, and now I can use this flange option. And this internal, we need to select the internal edge, the duck option, and click on OK. And for the opposite side, select the internal, and here again the duct. For that I need to select the open end. So after that, if you will select this type of uh, interference, you need to edit the sketches from here. If I am setting these values, if I am redrawing it and sketch it, I can add the values. So this way you need to manage these options. Dimensions for that. I can manage these dimensions as comment. And the bend position. The options you can use flush. So you need to, what type of locking system you want this in the sheet metal option. You need to select this way, and you need to manage this locking manually. So for that, this flange option will be helpful to you. Any other questions?
No, sir. Thank you.
Okay, thank you. So if you have select templates, I have to change its unit. How we can change the unit of our model? If when I am working with this model, I have set the MMNS template. If I want to change after the some of the modifications, for that you need to go File, Prepare, and the Model Properties. In the Model Properties, here you can see in the Units toolbar, you can change your system units from the MMNS, MMKS to MMKS. If you want to use as a inches, inch, pound, seconds options, you can set from here. Here I want as a MMNS, MKS. You can set from, just click on the set window, click on OK, and your unit will get changed for your model. Okay, how would you reference to the sketch from the 3D? Please explain freestyle topic. Okay. Okay, I will show once. Student version. Okay. Any other, if you have any questions, you can directly ask also. For the in the drafting window, I already shown that how we can take the projections. If I am opening the drawing, I will show once again. If I want the projection view, here is the projection view option is also available. Click on the projection view, and for which view you want to projection, just click on it, and whatever area you want to set the your adjacent projection, you need to just click on it. So this is the simple way. Otherwise, here is the one shortcut is also available. Click on this, and you will have this projection view shortcut is also available. Click on that, and you can set this projection also. So this way you can also set the projection. Can we make cap, but internal threads and external threads? For the internal threads and external threads, Thanks. Okay. Thank you. Freestyle. Yes. For the threading purpose, I will show one short example for it. Extrude on the top surface. You need to use this helical. Uh, you need to use this helical sweep option. So how you can use this helical sweep? I will show just a short example for it. Here is in the sweep option, helical sweep option is available. For this view, references, helix axis, uh, we need to define the helix profile, sketch, and line. Helix axis should be this, and we can draw the circle. Click on the OK. You will get this type of threading. If you want to show the threadings, you need to use this helical sweep option. So by using this helical sweep option, you can use, if I am changing the diameter, D. So this way you can add the threads for your model. Whatever the pitch you want to define, you can edit it and you can set the pitch between the two threads. Here you can see pitch value is 25. Here I can add the 10 value. It will get combined 20. Here you can see. So this way, by using this helical sweep, you can add the threads. Have you got this option? Internal threads, external threads.
Yes,
By
sir.
using those options, you can use this. How we can make the cap of bottle? Same way, cap of bottle, you can take the reference from the bottle and the diameter. You need to just model it by using the revolve command. You can easily create this cap. Okay.
Sir, we can't see the screen.
Okay, I am resharing it. Okay. Now you got my screen.
Yes, sir.
Okay. So any other questions? I think.
Sir, in my Creo app,
Sir,
there are
after collision detection,
so what should I do to get the other options, cannot and get basic options?
I don't didn't get. Can you please repeat?
Sir, I can't hear you.
Can you repeat, please?
Sir, in the Creo app, I have only one file and one home option. So what should I do to get the other options which are there in your app?
Which version you are working on?
Creo 7.2.
For the Creo 7.0, you need to you should have all these options.
Sir, I have only one file and one home option available now.
At this area, for on which area? You can share this screenshot of your screen on my WhatsApp number. So I will tell you that what is going wrong with your setup.
Okay, sir.
Okay.
sir, I have one question.
Okay.
Sir, after collision detection, it is necessary to redesign the product.
If we want to cross check or we want to redesign uh, on depends which type of constraining, which type of degree of freedom we required. For on that depends if you want to do the collision detection test at the specific unwanted area, you want to remove the collision. So at that time, we need to reproduce or do the necessary changes for this after doing the collision detection.
Sir, what is your WhatsApp number?
I will share it again in the chat box. 9960705372. So, any other questions? Can we stop here?
Thank you.
Chavan sir?
Yes, sir. Yes, sir. Sure.
Okay. If you have still any doubts or if you have do any modeling practices, you can share with us. So we can also promote you, your college, as well as we. So you hope our today's topics you all enjoyed.
Yes, sir.
Yes, sir.
Okay. So thank you. Tomorrow again we will meet on the 3 p.m. and with the different topics and different interesting models. So, okay, thank you.
Thank you, everyone.
Thank you, sir.
Thank you, sir.
So please feed again today we are going to share the feedback form. Please fill those